Good day, everyone, and welcome to where we are putting together solutions for students in the area of our Standard 5 Secondary Entrance Assessment. And in this video, we'll be looking at the SCA 2021 past paper. Specifically, we're looking at section 1, which are numbers 1 to 20. Don't forget to like the video and add any comments down below, so we can help create other videos to assist you in whichever areas you're getting problems with. We also have channels for the CXC Mathematics at Form 5 level and the CXC Add Mathematics. Don't forget to look at the description down below where we have given advice in how to go through working out for the SCA paper. Our paper has a distribution of questions in this first section, which are 20 questions, where the first strand in the SCA primary math level is a number, and that is tested for the first 10 questions. And the next strand, measurement, those questions are assessed in numbers 11 to 14, the next 4 questions. Geometry is then assessed in the next 3 questions, 15, 16, and 17. And the complete section 1, statistics, is assessed in the last 3 questions of the section 18 to 20. Let's now look at number 1, where the question asks, write the numeral represented below. And we can see this diagram shows us something similar to what we consider to be an abacus. Some of us could easily watch the answer and see, well, there's 1, 2, 3, 400,000, no 10,000, 2,000, so there's 402,000. And if you look in hundreds, 1, 2, 3, 4, 5, there are 500s and 110, 510. So some of us can watch it and say 402,510. Let's just be reminded, this is what it looks like for the 100,000, because there are 4 of those beans or balls to represent such. There's none for the 10,000, 2 for the 1,000, 5 for the 100, 1 for the 10, and 0 ones. If we think of putting the place value for them, we know that the 0 is under ones, the 1 will be under tens, the 5 will have a place value of hundreds. And remember, math is a pattern. It keeps repeating. So just as we have ones, tens, and hundreds, as we go on, it's still ones, tens, and hundreds. And if we continue to larger numbers, it will be ones, tens, and hundreds. What's the difference? The first set are all ones, so it's 510. And the second set of 3 will be 1,000. So each period gives us a certain value. So in the green, which we have for thousands, we have 402,510. Number 2, write the missing number in the box below. So 64 is equal to some number squared. And many of our students can easily watch that and they know the answer because they know their tables. So the answer is 8 squared. But let's be reminded a little bit that if we consider we have a square, only one square, then one side is 1 and the other side is 1. So that will be 1 by 1, 1 squared. So one small square forms a square of side 1. If we added another square to it, we'd have 2 squares together. Could they form a larger square? They can't. What about a third square? If we rearrange it, we still won't get a larger square. What about 4 squares? Could we rearrange it? Well, we can. We can shift it across here and we get one larger square, in which case the length and the breadth is 2. So we can say 4 small squares form a larger square of side 2. And of course, if we add a row below and a column on the right side, that's what we added in green, then that gives us 9 small squares form a larger square of side 3 by 3. And if we add 3 to the right and 3 and 1, 4 below, so we'll have them in a different color, then what happens? We have a larger square again. 9 and we added 3, that's 12 and 4, 7, right? So 9 and 7 is 16. So 16 small squares form a larger square of side 4. And if we increased it again, we would now add 25 small squares form a larger square of side 5. And we keep increasing, we get 36 of those will mean that we have 36 small squares form a larger square of side 6. And then going even larger, we have 7 across by 7 down. So we have 49 small squares form a larger square, one large square of side 7. And of course, our question now, which is what we had 64 squares, and those 64 small squares form a larger square of side 8. So 64 is equal to 8 squared. Let's go on to number 3. In this question in number 3, they're asking us to simply calculate 305 multiplied by 7. There are some students who can watch it and immediately work it out. I like to draw a little diagram so that students can see exactly what's happening. Let's consider we have a rectangle whose length is 305 and whose side is 7. We can break up that rectangle into 2 parts, into 2 smaller rectangles, which will take up the same area as the large one. And we can say, well, 305, we can break that up as well. We can say one side is 300 and the other side is 5. So, can we find the area of the large rectangle whose length and breadth are 307? Well, we can multiply. We have 7 times 3 hundreds, and that will give us 2100. And 7 times 5, 7 fives are 35. So what is the area of the entire rectangle? It will be 2100, 2100 plus 35. So that works out to be, if we add 0 and 5 is 5, 0 and 3 is 3, we have 1 alone, and we have 2000. So 2135. And that is our answer. Some teachers are okay with that. Some students prefer to write it like this, 305 times 7. So they worked it as if we had 7 times 300. That will give us 2100. 7 times 5 is 35 because 7 zeros are 0. So they'll work it as if it is a long multiplication question. Others prefer to write it, and their teachers show them this in class all the time. So let's be reminded. We have 300s there, 100, 200, 300, and no tens. And we have 1, 2, 3, 4, 5 units. So we have 305. And what we're doing, we're multiplying by 7, which means we have 7 groups of 305. 1 group of 305, 2, 3, 4, 5 groups, 6 groups, 7 groups of 305. And if we had to work that out, well, let's look at the units. We have 5 in each group, and we have 7 groups of those. So we can group them together, 5 and 5, right? That will give us 35. 7 fives are 35. Or we can group them, 5 and 5 is 10. 5 and 5 is 10. 5 and 5 is 10, and we have a 5 remaining. So if we have 10 units, we can replace that by 1 rod. I know many students are taught like this using the base 10 blocks by their teachers. So we'll show this method as well, just to remind ourselves how we're getting the answers. We have another 5 and 5, 10 units, which can be replaced by one rod, and another 10, which can be replaced by another rod. So what does that tell us? That the 7 groups of 5 units is really 3 groups of 10 and 5 units. So that's why teachers tell us cross the 5 and write the 5 in there, because we have 5 units. And what we have again, we have 3 tens. Now, what else do we have? We have 7 groups of 300s. So if we look at that, we wrote it out already, but we can group them a little more because that is 2100s. So we can split it up and have 3 and 3, 6, 7, 3, 9, and 1, 10 of those hundreds. And we have another 10 of those hundreds and 1 remainder. And what is 10 hundreds? That is 1000, a cube. And what's 10 hundreds again down below? 1000. So what are we left with? We're left with 100 and 2000s, which is what we have written here, 21. So we can cross the 1 and represent it as 1. That indicates the 100 above. And we have 2000 remain. So we can put that there. And our answer is 2135. Many different ways of solving the same question that you have been exposed to with your teachers in class over the years in primary school. Let's go to number 4. In this question, in number 4, they're asking us to divide 288 by 9. So there are different ways to do it. One way, we can just look at 90 of those 288. If I group 90 by itself, could I divide by 9 or break it up into 9 parts? Each part will have 10 in it. So that means I dealt with 90 out of the 288. Can I get another 90 from it? Well, if that's the case, then we can divide that next 90 by 9. And that will also give us 10. So we dealt with 90 and 90, which is 180. Do we have enough for another 90? I believe so. So we can do it again. So that will give us 270 we're dealing with. And 9 into 90 is another 10. So we have 270. What is remaining? 18. So some students prefer this method rather than the conventional one that teachers normally use. Different students like different ways. There are hundreds of ways to solve every single question. So we have 18, 9 into 18. We're going to get 2 groups. So we got 10 groups in the first one, 10 with the next, 10 with the third, and 2 more. So how many groups of 9 do we have in all? 32 groups of 9. Or we can do it this way, where we have 2 hundreds, 1, 2, 8 tens. So we have 1, 2, 3, 4, 5, 6, 7, 8 tens or 8 rods and 8 units. And this represents 288. And what do we want to do? We want to say 9 divided by 288. So if we look at the 200s, can I form groups of 9 from 2? I won't be able to do that. So maybe I can take that 100 and break it up into tens. And if we break it up into 10, 100 will give us 10 tens. Let's check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we break up the next 100 into groups of 10. So we have 10 again. So we have 10 and 10, 20. And we had 8, 28. And you can see there, we're now trying to form 9 into 28. Can we form groups of 9 from here? Well, there is a group of 9, 3 and 3, 6 and 3, 9. So we have one group. We have a second group of 9. We have a third group of 9. And we now have one remainder. So that means we're going to have 3 groups of 9s and 1 remains. So we're putting the 1 there. And what is that 1? That is one group of 10. If we have one group of 10 and we have 8 ones, we can change the group of 10 into 10 ones. So we have 10 and 8, 18 units. Can we form a group of 9? Here we have one, and we have a second group of 9. So that means we have two groups of 9. As such, the answer is 32. So doing the short division or long division, this is what it means. It's just a little reminder for ourselves. Now go on to number 5. Write 37 over 5 as a mixed number. So if we're considering that, where we're taking the improper fraction and change it into a mixed number, well, some of us could watch it and we know the answer is 7 and 2/5. And let's be reminded, how did that happen? Well, we could use different shapes. Let's use a circle. And if we're considering we're taking a circle as the whole, and we look at the denominator, let's concentrate on what number is that? 5. That means we need to take the circle and break it up into 5 parts. So if we had the first circle, the complete circle would mean what? We had a total of 5 parts. We can represent it here as well. So the first 5 parts give us 1 whole. So 5/5 is 1 whole. I can do another circle, and that will give us another 5 parts. So that will be 2 wholes. So how many parts did I have in all? 10 of those small parts, 10/5. And that gave us 2 wholes. And I add a third one, well, that will give us another 5. So that will be 10 and 5, 15. So 15 of those fifths is the same as 3 wholes. Let's go again. We can add another one. So that will give us another 5. So that will carry us to 20 of those small parts. And it will give us 4 whole circles. We're almost there. Let's add another one. So that will give us 20 and 5, 25/5. 25 of those parts will make up 5 large circles. We can go again. We add another 5 to it. And what's going to happen? That's going to give us 30 of those parts. And those 30 parts will make us 6 whole circles. We can count them 1, 2, 3, 4, 5, 6. We're almost there. We have another circle, which give us another 5, and that will carry us to 35/5. That means we have 7 wholes. We have 35/5. We need to get 2 more only. So we're going to bring up a circle, but not the entire thing. We don't need all 5. We just need 1, 2 parts. So those 2 parts will make us a total of 37. As such, that gives us 7 whole circles and 2 remainders or 2 small parts. So 7 and 2/5. We can also do it like this, where we say we have 37, and teachers like to do it this way, 5 into 37. 5 into 3, well, cannot. So 5 into 37, we get 7. That's normally what they say in class. And the remainder is 2. So that is 7 wholes and 2/5. Go on now to the next question. Number 6. 3 and 5/9 minus 1/9. Some of us could watch it easily and we can tell. Or we can look at this model where we have 1 whole with 9 parts, 2 wholes with another 9 parts, 3 wholes with another 9 parts, and 1, 2, 3, 4, 5. So this represents 3 wholes and 5/9. And what are we going to do? We're going to subtract one of those parts, 1/9. So what are we left with? 3 wholes and 4/9. There are other ways to do it as well. We can split it up and say 3 and 5/9 minus 1/9. 5 of the same parts minus 1 of the same part is 4 of it. So 3 and 4/9. We can also represent it using a number line to give us an idea of what's happening. If we think about 0, 1, 2, 3, 4, And we're looking at 3 and 5 ninths. That's actually between 3 and 4. So let's pull it out a little bit and let's expand it so we can see it a little easier. And let's consider that's between 3 and 4, and we have to break it up into how many parts? Into 9 parts. So if we're counting the parts, that means we're going to have 8 lines. It's going to give us 9 parts. So that's 3 and 1 9, 2 nines, 3 nines, and so forth. And the question says 3 and 5 nines, so let's indicate exactly where that is. And what are we doing? We're substituting 1 9 means we're going to the left. Right? We're going to the left 1 ninth. So our answer is 3 and 4 ninths. Go on to the next question now, number 7. Draw a circle around the 4 that has a value of 4 tenths. So if we consider here, the question actually says 44.44. So we have to circle which 4 has the value of 4 tenths. So this is a place value question looking at the idea of values. So let's remember, because of the decimal point, that 4 to the left of the point indicates it's a whole or ones. So normally we can use a base 10. The teachers do it differently. We can use this here, the square, to indicate those are ones or wholes. And if we have 10 of them put together, we'll call 10 ones, we'll call them a 10. 10 of those squares put together will look like this. So this is giving us the idea in terms of base 10, because teachers teach it with this all the time in classes. I'm sure your teacher has done that. So we have this large cube, that's tens represented. We cut it. So 1/10 of that would be a square, which represents ones. If we cut that again, what is 1/10 of ones? That will be tenths. And it will be represented like that, like a rod. And we could break it up even more. Remember, we have our decimal point there to show which side is greater than 1 and what is smaller than 1s. And if we break up the tenths again, we're going to get hundredths. So if we break up that rod, we're going to get those little units. So which one of those 4s indicates it has a value of 4 tenths? Well, this one, the first one to the right of the decimal point. Let's go on now to number 8, where you see that in number 8, the question is asking us to write one of the following symbols in the box below to make the number sentence correct. So we have 0.63, we have a box, and we have 0.36. Is 0.63 greater than, equal to, or less than 0.36? So, because so many teachers explain decimals using the grids, right, or the decimal squares, let's use one of these. Let's consider the whole thing to be a whole, and we break it into 10 parts. So each part is worth 0.1 or 1/10. So in this case, we have 0.63. So if we had 0.6 and we would like to shade that, that's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. 6/10 or 0.6. Now we actually want 0.63. That 3 will be to the hundredths value. So if that's the place value, then we need to also be able to split it up 10 across. So those are 100 hundredths. And that makes up a whole. Many teachers have their students shading this in class, so it is doing the same example. So right now we have 10, 20, 30, 40, 50, 60 of those small squares, or 60 hundredths shaded. How many hundredths do we need shaded? 63. So we need to shade 3 more. So that is a physical representation of what 0.63 looks like. And let's compare it to 0.36. We'll do the same thing. That 0.3 means 3/10, so we can shade 1/10, 2/10, 3/10. And we want to also cater for the idea of 6 in terms of hundredths. So we're going to do the same thing. And we already have 10, 20, 30 hundredths shaded. So we need 6 more hundredths. So we can shade that. So if we compare the left side and the right side, we can see which one is larger and which one is smaller. So let's look at the symbols again, right? Unless we reminded, let's look at the one on the right hand side. If we look at it there and let's make it a little bigger for us to see, it sort of looks like our left hand. So that looks like an L for left hand. And L for left, and it also means L, that symbol is for less than. So is 0.63 less than 0.36? If you look on the left side, there's more shaded on the left than on the right. So that's not the case. What it is greater than. So they are more shaded on the left side, so that is greater than what is shaded on the right. So we can look at it as a number line. And if we put up the number line 0.10, 0.20, right? We wanted 0.63. It's somewhere between 0.6 and 0 and 0.70. So we just indicate a general idea where it is. And 0.36 will be after 0.30 and 0.40. So we could clearly see the one on the right side in red is larger than the one in green. So 0.63 is greater than 0.36. All right, let's go on. Let's go look now at the next question. In number 9, it's asking us to do a percentage question. Calculate 40% of 500. And there's so many different ways that teachers show students here. And one of the ways is we can look at the same idea of this very large square, consider that to be a whole, and let's say that square is worth 500. And we could break it up into 10 parts and 10 by 10, 100 parts. So we could say 100 blocks is equal to 500. Or in this question, we could say 100% is equal to 500. So if that is the case, what is 1% equal to? 1% is equal to just 5. And how many percent do we want? We want to calculate for 10, 20, 30, 40%. So if 1% or one block is 5, 40% will be 40 times 5. And that works out to be 200. That's one way to do it. Another we could look at, you could think of the idea of writing a number line up to 100%, which is everything. So from 0%, 10, 20, 30, just a little sketch. And what did we say? 100% is the entire thing, which is, if we start at 0, it is 500. If 100% is 500, what is 10%? 10% is 50, which is one strip that, or one column that we shaded. Ours 20%, 100. Ours 30%, 150. And 40%, which is what they're asking us to find 40% of 500, that is 200. Of course, some teachers prefer this method, 40% of 500, to show the students. So that's 40 over 100 multiplied by 500. And we can cancel 2 zeros below and 2 zeros across. 5 times 40 is 200 as well. There are many, many different ways to solve this question. Let's go look now at next question, where we've reached the middle of section 1, which is number 10. Daniel used the coins and bills below to buy a t-shirt. So look at the coins. He had a $5 bill, $1 bill, $20 bill, $1 bill, $50 bill, and those 6 coins. So the question is asking, what was the cost of the t-shirt? Because he used all this money. So let's see if we can add it up. We had a $50 and we had a 20, 50 and 20 is 70. And we had a $5, 70 and 5 is 75. We had a $1, 75 and 1 is 76. And we had one more dollar. So that will give us $77. You can check it back for yourself. And now let's count the coins. We had 25 cents and another 25 cents, that is 50 cents, and another 25 cents, That's 75 cents. And 10 more cents is 75 and 10, 85 cents. And another 10, 95 cents. When we add this last 10, what are we going to get? 95 cents and 10 cents is $1.05. So how much was the cost of the t-shirt? We need to add these things. And when we add it, we're going to get only 5 cents there. And when we add the dollars, 77 and 1 is going to give us $78.05. And that was the cost of the t-shirt. Let's now go on to number 11, where in this question, they're asking us what is the most appropriate standard unit for recording the height of a room? If we're measuring the height of the room, could we use kilometers? Kilometers are a very large unit of distance, and that won't be able to fit in the room. Could we use meters? Maybe we can measure the height of Miss or Sir in class in meters. Could we use centimeters? Well, centimeters is small and it's going to take a lot of those centimeters to measure the height of the room. And millimeters is even smaller. So it's going to take hundreds and hundreds of those millimeters to get the height of the room. As such, the best unit to measure the height of the room is meters. Let's now go on. As we go on to the next question, which is number 12. And in number 12, they're asking us to complete the statement below. 17.42 kilograms is equal to how many grams? So this is a simple conversion. So let's be reminded that if we have a scale and we put 1 kilogram on one side, it will be balanced with 1,000 grams. Your teachers would have done this in class all the time with you. As such, if we had that 1 kilogram, it's the same as 1,000 grams. So what about 17 kilograms? If we had 17 kilograms on the left, how would that be balanced on the right? We would need 17 times 1,000. So we would need 17,000 grams. And how do we multiply by 1,000? Look where the decimal point is for 17. And we move it 1, 2, 3 places to the right. That's a shortcut because we're multiplying by thousands, which has 3 zeros. So our answer will be 17,000 grams. So as we've gotten 17,000, let's look at the actual question. It's slightly different, but the same conversion holds, which is 1 kilogram is equal to 1,000 grams. And then what we want to find for this question is what is 17.42 kilograms. So if we look at how we work 17 kilograms to the left, convert it to grams, we multiply by 1,000. So for 17.42 kilograms, we're going to do the same working. 17.42 multiplied by 1,000. And what does that mean? It means that we have to look at the decimal point and we have to move it to the right because we're multiplying. And how many places do we move it to the right? We move it 3 places to the right because there are 3 zeros in 1,000. So when we move it, our final answer will be 17,420 grams. Let's now go on to the next number where it says a watermelon on a scale is shown below. So if we look at the scale, we can clearly see the watermelon. And if you notice, the watermelon scale is in kilograms. So let's see if we can work out what the question asks us. What is the mass of the watermelon in kilograms? So what do we have to do? If we look at the needle, what you can extend it somewhat, and we can see it's passing directly between 3 and 4 kilograms. And what's the direct middle of 3 and 4? 3.5 kilograms, or 3.5. Let's go on as we move on to number 14, where the question says, Kelly arrived 10 minutes late after the start of a test. No additional time was given, so Kelly lost 10 minutes of the test. The start time was 8:45 for the test, and the end time was 9:40. But Kelly did not start at 8:45 because he came 10 minutes late. How much time did Kelly have to complete the test? So there are a couple different ways to do this. Let's start by looking at it as how much time did Kelly have to complete the test? So there are a couple different ways to do this. Let's look at it as it was using an analog clock. Because our students are so familiar with that, let's set up the clock, make a quick little sketch. And what's the start time? It starts at 8. So let's put the hour hand there at 8. And now we're going to look at the minutes. And when we're doing that, let's draw a vertical line just to give us an idea that at the top, what minutes is 0 minutes, and at the bottom half is 30, because we're cutting the hour into a half. And if we draw a horizontal line across, at 3, it will be 15 minutes, and at 9 will be 45 minutes. So what do we have here? We actually have the 15 times table. 0 15s are 0, 1 15 is 15, 2 15s are 30, 3 15s are 45, and if we went back up again, 4 15s are 60. So now let's actually put in the start time. We already have the hour at 8, and let's put in the minute hand. Oh, before we do that, let's put in the minutes: 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. And of course, 60 is back to 0. So we now put in the minute hands, and the time tells us it's 8:45. And what happened? If we look back at the question, Kelly did not arrive at 8:45. Kelly arrived 10 minutes later. So let's move the minute hand, 5:10. So now what's the time? 8:55. Now, Kelly is now starting the test at 8:55. And the question is asking us how much time did Kelly get to complete the test? So from 8:55, we can move 5 minutes across, and that will carry us to 9 o'clock. So 5 minutes carries us to 9. And from 9, we moved 5, 10, 15, 20, 25, 30, 35, 40, until we're at 9:40. So we moved 5 minutes to reach 9, and then 40 more minutes. So 40 plus 9 is 45 minutes. Another way teachers allow students to do it, they guide them by looking at it as a subtraction. 9:40 minus 8:55, not 8:45. Remember, Kelly came 10 minutes late. So how do we do the subtraction? 0 minus 5, that will not be possible. So we have to borrow from the 4, which means we're removing one of the tens from 4 and carrying it across. So we'll have 3 tens left. And when we carry that across, we will have 10. And how much was that there? 0. 10 and 0 is 10. So 10 minus 5 is 5. So we're dealing in minutes. And now we actually have 3 tens, and we have to subtract 5 tens from that. That is not possible. So we need to take from where? From the hours. So instead of 9 hours, it becomes 8 hours. And when we carry 1 hour across, how many minutes or how many 10-minute intervals will there be? It'll be 6 10-minute intervals. So 6 and 3 is 9 10-minute intervals minus 5. 9 minus 5 is 4. And of course, 8 minus 8 is 0. So our answer is 45 minutes. We can use it using the analog clock, which students can sketch, or use it using the formal algorithm. Let's move on now to the next question, which is number 15, where they're asking which of the shapes below, A, B, C, or D, has a uniform cross section. A is a cone, B looks like a cuboid, C looks like a globe or ball, and D looks like a prism. Sorry, like a pyramid. So let's enlarge A a little bit. And if we look at this cone, we can think about it as there's a line coming down the center or axis. And if we had to draw the shape at the bottom of the cone, what shape would that be? It would be a circle. And if we cut halfway up the cone and look at the shape, we will also get a circle. And if we cut even higher up and we look at that shape, it will still give us a circle. So we're still getting the same shape throughout, which means that there's some sort of consistency. However, uniform cross section means it has the same shape and same size. And are our circles remaining the same in the cone? Clearly they're not. Let's look now at the cuboid or cube. And at the base, it gives us a rectangle. If we took a cut in the middle of it, we would still get a rectangle of the same size. And if we looked at the top of it, we'd still get a rectangle of the same size. So it's the same shape and same size maintained throughout. So this has uniform cross section. Let's look at C, where we're looking at our ball, our globe. If we look at the center of it and we actually draw a shape there, if we were to cut that ball there, then we would be getting a circle. And if we came a little closer to the right side and we cut it there, if this was a solid sphere, then we would get a circle as well, but a smaller circle. And if we came very close to the end and we cut that, we would also get a circle, but a smaller one. So we're maintaining the shape, but the size is changing. So therefore, it is not uniform cross section. And for the final one, let's look at the pyramid. At the base, we may be getting a rectangle. As we go higher up, we'll get another rectangle, slightly smaller. And by the time we go up again, we'll get a very small rectangle. As such, the only shape which remains the same size and shape when you cut it at any part of it will be the one at B. Let's now move on. So we're going to look at number 16, where they're asking us that the hour hand of the clock in that diagram moved from 3 to 12. So we can see there, it's indicated with the arrow. The question is, how many quarter turns did it make? Let's bring up the cross line so we can easily see, cutting it from 6 to 12 and 3 to 9, so we can see the clock face in quarters. And we're starting at 3. And if we draw a minute hand or a hand here to see movement, and we rotate that quarter turn, we can see moving from 3 to 6 gives us 1 quarter turn. And if we turn again from 6 to 9, we get a second quarter turn. And if we move from 9 to 12, we get a third quarter turn. As such, 3 quarter turns will be made by the hour hand in order for it to move from 3 to 12. Let's now go on to number 17, where the question says, which angle in the shape shown below is less than a right angle? So we have this shape ABCD, and we want to know which of these angles A, angle B, C, or D is less than a right angle. So let's bring up a little circle just to remind us and cut it into 4 parts so we can easily see where a right angle is, or a quarter turn. So if we take that quarter turn and slide it across at A, is A less than a right angle? No, it's not. A is the same or equal to a right angle. Let's try it at B. If we slide it across, we have to turn it a little bit for it to fit. B is equal to a right angle. So A and B are equal to a right angle. We're actually looking for the one which is less than a right angle. Let's carry it across to C. When I carry it, I have to spin it. Is C less than a right angle? No, it's not. It's more. And let's try a D. We're going to rotate it a little bit. And look what happens. D is less than a right angle. As such, Which angle in the shape shown below is less than a right angle? It is the angle D. Let's go to the statistics part of the section 1, where number 18, question asks, the mean of 5 numbers is 86. What is the sum of the 5 numbers? So, because so many of your teachers teach it this way, using a picture to show you what it says, let's look at it like this, where we're saying that if we pick any 5 numbers, a very large number, a smaller number, a very big number, maybe an average number, and one a little more. And we're saying that when we have these 5 numbers, the mean or the average is 86. What does that mean? When we say it is 86, it means that if we redistribute the amount in each one of these columns so that all the columns are level, that height will be at 86. So let's take a look at the first one. Let's imagine we cut it up into parts. And what's another tall one? The green one. Let's cut that into parts as well. So if we take there and we slide it across on top of the yellow, look, we can see yellow and purple are about the same level. Green is a little too high, so we need to slide that down onto the blue, and we have a little extra from the first column. And now all 5 have the same value or the same height. They may be made up of other parts, but each one has the same amount. So we can say this is a way of representing the average as 86. So we don't actually need to know how much we had in green or blue or yellow or so forth. We can say now, since the average or the mean is 86, then the total, which is the sum of the 5 numbers, can be done by adding 86 and 86, 86 for the green and 86 for the yellow and the peach and 86 for the purple. So we can, how many 86 do we have? 5 sets of 86. So we can find the sum by saying 86 times 5. Or you can add 86 5 times. And of course, 5 sixes are 30. So we can carry the 0 and put it across in the ones. And we have 3 tens remain. And we still have 5 groups of 8. That's 40 and 3. So that will give us 3 tens and 4 hundreds. So the sum of the 5 numbers, when you add up the 5 numbers, whether some are larger or smaller, right? The fact that they will average out, that they will eventually have 86 in each of the 5 columns, means that the total that they start with is 430. Let's go on now to number 19, our penultimate question in this part. Complete the tally chart below to show Jahim's cricket score. So the table was given with a little more information like this, but I'm using it to help us revise. We want to find out for Jahim. So Ryan's tally was given with this whole row across 5 and 510 and 515 and 520, 21, 22, 23. That whole row was given. So they gave us the tally for Ryan. For Ariel, they also gave us the tally 1, 2, 3, 4, and one more is 5. 5 and 510 and 515, they gave us that. For Mark, they gave us 1, 2 strokes. And the question is really asking us, complete the tally chart. So what is happening is this is a column, and this table was given with this information, and they're asking, what is Jahim? Jahim is 17. So we can add 5. Do we need any more? Yes, we need another 5. 5 and 5 is 10. Is that enough? Not yet. We need to add another 5. So that's 15. 5, 10, 15. Do I need to add another 5? Another 5 will carry us to too much. So after 15, we need to have 1 stroke. That will carry us to 16. And we need 1 more. So that is 17. As such, this is the tally chart representing Jahim's cricket score. And for the final question now, in section 1, number 20. The table below shows the places a group of students visited. So 6 students went to the zoo, 9 students went to the Science Center, 12 students visited the museum, and 6 students visited the beach lake. Which place represents the mode? Now, one of the things which students get confused with, they remember that MODE is mode, and that means MOST, it's most. So many times when students watch this, they look for which number is the most, which in this case is obviously 12, right? But look at the question. When they're asking for the mode is not the number of students. It is which place that most students visited. And the place that most students visited will be the museum. So that is the mode. So we have now come to the end of SCE 2021 past paper questions for this video, which is dealing only with section 1. This series started with SCA 2019 and it's progressing until our next paper, which we'll be producing, is 2022. Don't forget to look at the description down below where we have given insights into how to handle the primary school math. Goodbye, everyone.